Hello everyone, welcome to the lecture series of Emporathum Numerical Challenge. Let's see the solution of the last question. So the last question was based on the DFS tree, which says if a DFS of a directed graph contains a back edge, any other DFS of the same graph will also contain at least one back edge or not. So we have to specify whether this statement is true or false. So let's first understand what do we mean by this statement. So let's understand what is a back edge. A back edge in any DFS traversal is an edge that connects a vertex to one of its ancestors in the DFS tree. So let's understand this with the help of an example. Suppose I take a sample graph as, let's say this is A, this is B, this is C, this is D, this is E, and this is back to B. Now if I do a DFS traversal of this graph starting from A, then from A we start with A, then we go to vertex B, we visit vertex B, then from B we go to C, visit C, then from C we go to D, we visit D, then from D we go to E, we visit E, and from E we can see that there is an edge back to B, so which is already in the recursion stack. So this E to B edge, this is a back edge, since it's already taking us to that particular vertex which we have already visited. So this is the back edge. Now if I try a DFS traversal on the same graph but in the different order. Let's say if I visit, this is my graph starting from A, this is B, this is C, this is D, this is E, and this is back to B. Now if I do a different DFS traversal of this graph, let's say I start from C, we start from C, then we go to, let's say D, we visit D, then from D we visit E, then from E we visit B, and from B we it's taking again to vertex C, which we have already seen. So this is a back edge, right? So we can see that no matter where you start, as long as you explore this cycle, you will encounter a back edge. So we can see this has happened because there is a cycle which is persisting in this graph. Now from this, what do we conclude? We conclude 2 points from here. First is that the presence of a back edge implies a cycle, right? This we have already seen. Second, a cycle is not dependent on the order of DFS traversal. This we have already seen, as we have taken a DFS traversal in 2 different order and we are encountering a back edge. So from this, what do we conclude? That if any one DFS traversal contains a back edge, or we can say a cycle, then any other DFS traversal of the same graph must encounter at least one back edge. So this statement holds true. So see you in the next video with the next Emporathum numerical challenge.